Hello YouTube viewers, welcome to my channel Science to Technology. In today's show, Computer Wednesday, we're gonna talk about Raspberry Pi Compute Module 4, which has been released very recently. So let's dive right into it. So first you have to understand why the heck Raspberry Pi, which is a surprisingly small computer, aka size of a credit card, why the heck you have to make it even smaller? Now reality is Raspberry Pi has become much bigger than even the manufacturers expected. It's like it has went from okay, a lab tool to like geeky tool to hacker kind of tool to like whoa, people are making actual product out of it. So Raspberry Pi Foundations thought of something very clever. It's like okay, most of the time you don't need all the hoo-ha and all the IOs that this puppy has. Most of the time you will need barely few things, or maybe you want to control what the heck you want on this puppy. So idea is you're gonna do a prototyping. Basically this is my idea. Let's say for example for a NAS or a security camera or whatever have you, you're gonna be like, this is my design, I want to do this. You're gonna make the prototype on Raspberry Pi, then you're gonna do what we call custom PCB. Now making a whole compute module on a like a board and something like that, it's doable. That's how computers are manufactured, that's how motherboard is manufactured. But the moment you have to ask any manufacturer to add silicon on it, the price will go up from let's say $1 per PCB to $500 per PCB, especially if you are not ordering thousands of them. So reality was most people can go from Raspberry Pi to PCB design, but they could not go to full extent where they're like, no, this is my whole product. So Raspberry Pi came up with the idea, just make a basically adapter for Raspberry Pi, and they made the Raspberry Pi into a sodium slot. So idea was you make your prototype, you figure out the code, you figure out the wiring, you do everything you have to do, then you make a basically complete final product which you want, basically with the IO that you desire, which the configuration you desire, and then we just gonna slot in the silicon. It's just like it's almost like basically making a motherboard. So you are making a simplified motherboard, and Raspberry Pi Foundation is selling you the whole CPU on a motherboard, so to say. So you don't have to think about other things. Basically, you can manufacture final finished good utilizing this technology, and there are actual products in market as of now which utilize this, like as in like companies wholesale with a warranty and all that jazz. So what about compute module 4? Now you have to understand Raspberry Pi, when they started to keep the cost down, they started to utilize RAM format. The benefit of that is like you go to let's say a company like JSL PCB, it's like bro, give me a female slot for DIMM slot. They're like, yeah, we got this, no problem. Most manufacturers like, bro, we got this. And this was big enough that if you are strong enough and you are resilient enough, you can make it out of breadboards if you want to do that. Not breadboard as in like perforated board. If you want to do that, it could have been done, but there was some fundamental limitation when they were designing this compute module 4. They wanted to change the core architecture. The reality is compute modules in past, they were very compromised equipment, basically underclocked, low powered, less RAM options, less like they were very crippled in certain ways, so to say. So Raspberry Pi this time is like, no, we will give you a GG system, basically a system as powerful as we can make it within the current technology. So this time the slot was a limiting factor. Basically it did not have enough pins, it did not have enough current carrying capacity. They're like, dude, this will not do, so they have to change it. Now this will be very painful, because before this, even if you had let's say a system for Raspberry Pi 2, you can easily upgrade to Raspberry Pi 3 or downgrade from 3 to 2. If you're like, dude, I don't actually need that compute power, might as well use a cheaper equipment. Many times people want to do that, like, because price is a serious thing. So this time they are changing us. So fundamentally it does break compatibility, but does give them a lot of new options, so to say. So they are going from sodium slot, which was DDR2 based, to 100 pin mezzanine connector. Now you're like, what the hell is this mezzanine connector? Just open up any modern smartphone, all of them have that. Now mezzanine connectors are kind of custom, so to say, because like you can buy them from like 4 pin wide, 8 pin wide, 20 pin wide, 100 pin wide, like they're kind of custom. But it's a quote-unquote industry standard. It's like the manufacturers knows how to build this. It's not, you don't have to worry about it, manufacturer have to worry about it. Now core changing, no more limitation. This is why they had to do that, and they have like 2 of these pins, aka 200 points of connection. So they listen to the communities. Like the whole reason why Raspberry Pi is successful, why hundreds of alternatives came and went, the sole reason is because of the community. And this community told them, hey, we want this, and they try to answer all of the prayers, so to say. So this puppy has wireless. So if you are making a Raspberry Pi equipment which is running on a basically what we call plastic box, simple normal device, you can have Wi-Fi directly. You don't even have to add antenna, because the PCB has it already. You don't have to do that. Now imagine it this way. Let's say you want to make something outdoor, something more robust. Problem is Wi-Fi will not work if you have a robust case, specifically metal based one. So they have an antenna connection on the board itself. You don't have to make a PCB trace of that. It's like, we got this, no problem. Then Ethernet is a serious thing. You want to utilize it. You don't want to, okay, I'm gonna lay down a PCB, then I'm gonna buy a manufacturer who sells a specific chip. Again, doable, many people have done it. It's just extra step which people did not anticipate it. So here it's just like draw out these 8 wires and tada, connect your Ethernet and go home. So done. That's also taken. So you don't have to add that silicon there. Now memory is a very serious thing that to this day I don't understand why the heck Raspberry Pi still relies on micro SD card, and you have to either brick it compatible it or blah 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 to that. This time they're like, no, we'll give you eMMC. Basically this is like a memory module used in your mobile phone. Again, a bit of lower quality, so to say, but you can buy this. Again, if you don't need it, there is a zero option where it's like zero amount of memory pre-built into it. But if you need it, you can go from basically 8 GB to 16 GB to 32. Now be mindful, this we are talking about Linux or even Android. 32 GB is more than enough to run a whole OS. And this time, because of the SoC upgrade, SoC has a PCI Express lane, so to say. Now those lanes were used in normal Raspberry Pi to give you USB 3.0. This time they are not doing that. They are like, okay, this is a PCI lane, there is like a whole world of compatibility tools available for that. Here's the, we're gonna give you that, and you're gonna figure out what you want to do. That consequence, you're gonna lose USB 3.0, but you can add 4 USB 3.0 if you want to, or you can add like 4 SATA ports if you want to. It's up to you. So they are giving you that pin out. So pin out will allow you to directly have PCI Express 3.0. So if you want to go bonkers, if you're like, hey, I'm making a basically a keyboard which is a full computer and you want to utilize the system, you can go with 8 GB RAM, which is good, like especially for Android or Linux. That's good. 32 GB, more than enough for as like a primary OS system. Wireless inbuilt, awesome. And that will cost you $90. Now I'm like, $90 for Raspberry Pi, that's a bit expensive. Yeah, but for the performance you are getting, that is tangibly good. And not to mention, you're not supposed to buy 1 or 2 of them. Again, for practicing, for experiencing, or making custom parts, awesome. But that's not the end game here. End game here is like you're gonna order, let's say 1,000 of these, 10,000 of these when you're making your product. So that time price will go down. So this was like a bulk kind of price. I'm pretty sure the price will go down. Now, whenever this sort of modules are released, generally there is a practice board with it. It's like, okay, you can see that even in NVIDIA, when NVIDIA released Jetson Nano, so to say. So it was like a module, then a board was like directly in the box. This time a board is sold separately, so you have to buy it. Don't expect like you bought the compute module, the board will come with the buy. But you can buy this board. The reason for this board is just basically to teach you how the heck you're going to design the PCB, custom PCB. You need to do that, and this is like a kind of early testing ground for everyone who wants to learn and adapt to this. So this has the core thing that they have changed. The silicon requirement is gone down. So basically this giant board barely have like few silicon chips in. Like again, it has resistor, traces, capacitor, all that jazz that any Tom, Dick and Harry manufacturers can handle, no problem. Basically you want to reduce the number of silicon. So silicon power rectifier side has a little bit is there for real-time clock, but practically speaking, you can strip down every single bit of silicon and it will still work. They even integrated the power delivery rails into the system. So that's the whole point. The silicon count is going down. You don't like a low level graduate can handle this puppy at this point in time. You can design it in that way. And PCIe 1X Express bus, that is directly available now. So if you can find something that works on Linux and works on ARM based, be mindful, almost everything works on Linux, but Linux ARM based, that's a very short list. So right now if you want to buy this and be like, I'm gonna plug this graphics card or this basically SATA card or SATA plus USB combo card, be mindful, does it have driver for ARM division, which is very small. So right now you have to check compatibility at this point in time. It's not universal, but there is some good news in the horizon, simply because Windows is now slowly starting to port the whole Windows Microsoft basically kernel, so to say, into ARM, because they want to make thin and light laptop like Surface and all that jazz. Those are utilizing ARM system. Again, they want to utilize ARM to its full potential rather than shipping you like, you know, a folding ARM display which is like, you know, Android powered. They want to go to Windows, but like again, they have to port the code thoroughly, and this would be the second time they are trying it. So let's see if that works out. This puppy will randomly go from niche tool to like, damn, every Tom, Dick and Harry is buying this. So a lot of things there, and it has a real-time clock. Now be mindful, you are giving up USB 3.0, so you can access this, and they have already tested like 2-3 cards which you can buy from open market and like just plonk it in there and get USB 3.0 if you really need that. Or you can plug a NVMe. So for some reason, if you really need to get upwards of like 300 Mbps read and write for Raspberry Pi, which is mind-bogglingly fast, you can do that. Real-time clock was a very serious misstep that to this day I don't understand why the heck it's not a standard part, but at least they have added it on this system. So you can basically replicate this if you want to. And all the HDMI port, you can see it's just a simple trace. You look at this board, it's like, okay, trace, done. You don't have to do anything fancy for that, and that's the whole selling point of this. So silicon has that much compute power in that, so you can have like 2 HDMIs full size this time. So awesome. And then fundamentally, that's the core logic of it. This is not as the, like, end all be all of it. It's just like to teach you what you should do. IO board. Now, what about the capability? Like, what you can actually do? Fundamentally, Raspberry Pi started as a very niche tool where people were doing niche things with it, and slowly over time, it started to become more and more and more capable. At this point in time, it is surprisingly close to a low-end PC setup. Fundamentally, if you do most of your work on web, basically all you do is like, if everything you do can be done on a browser, you can utilize Linux right now on a Raspberry Pi, and you will be fine. You will be like, I got this. And they have solved all the video encoding issues by utilizing a proper dedicated GPU that can handle H.265, so you can do a lot of web video browsing and all that without drop frames. 4K, it's now manageable. So fundamentally, it's coming to a point where it's like good enough PC for normal everyday folks. So that's awesome. And again, if the Microsoft pulls through, this will randomly go from one day, who cares about Raspberry Pi, to like, damn, this is like, the most highest selling computer. So that's there. And the fact that it needs less complex PCB to make into a final product opens up a whole new avenue. Like even normal people, because you haven't seen so many ads of JSL PCB. Imagine like hundreds of people, hey dude, I can make this module. Another is like, I can make a module. Before that, it was like, yes, you can make a module, but it was like you have to buy a supplier that gives you silicon, and that is surprisingly difficult. If you ask anybody, capacitor, resistor, variable, we got this, no problem. You're like, okay, buy this network chip. You're like, what? So fundamentally, simplifying that silicon department was awesome. Now we can see surprisingly amazing thing done if somebody utilizes that. True network attached storage is now possible because that PCI Express breakout board, you can tangibly utilize, let's say, just PCI 1.02 for hard drives. Fundamentally, you don't have to do fancy hoo-ha to that. So that's amazing. And very large clusters are possible because if you want to teach a lot of computer students like how cluster computer works or how a supercomputer works, fundamentally you have to teach them by physically building it, because in software everything works, in virtual world everything works. The moment you start in real life, it's like nothing works. So how do you train for that? Like you can try to use multiple old computers, but the problem is they are fundamentally slow and fundamentally more power hungry, and you don't want to pay like a lot of electric bill. And a proper supercomputer or cluster computer, they cost millions of dollars. So Raspberry Pi to the rescue. Low power, and the fact that you can have hundreds of them, like, so you can teach people. It's like, dude, see, the oscillators will never be absolutely synced. How the heck you gonna write a code that can handle off sync clock data transfer? Like how the heck you manage all these things? Like how the heck you manage lost data packet, which only happens in real life? So again, all these things makes it amazing teaching tool. So a lot of people jumped into it. You type Raspberry Pi supercomputer, like you're gonna get hundreds of it. You're like, whoa, why the heck people are spending so much money? That's the most amazing teaching tool, and you can do some practical things with this. Like some people have figured out like actual use which only Raspberry Pi can do. So imagine it's like, it's mind-bogglingly awesome. So because of the old design, there was some serious limitation with power delivery and actual capacity. It was not very oomfish. Did not have like whoa kind of power. So they are solving that issue. So in new generation, fundamentally it should be able to go to whole another level. Even though Raspberry Pi in the past could have gone there, but because of like module limitation, it was not going there. This time the module won't be a limitation, and the manufacturers who are selling like hundreds of these boards, they flat out, all of them came out. It's like, yeah, we are working on it, and Raspberry Pi Foundation kind of works in together with them. It's like there is a very tight knit community there. So they're like, yeah, we are working on it, and by the January 2021 we should start to see those boards reach the market. So it will take a bit of time to reach masses, simply because again they changed everything, but good things are on the horizon. So this was my presentation on Raspberry Pi Compute Module 4. Hopefully you liked it, learned from it. In that case, please click the like button. If you didn't like it, didn't enjoy it, I urge you to press dislike, press it twice to show me extra disappointment. Please leave a comment, because I try to reply to all of them. Subscribe, press the bell icon if you're free, and as always, thanks for watching.